Hi guys! Wow, you came back! I can't believe it! I thought my tutorials were horrible. Yeah. Okay. So, let's see... what is there to see? Oh, today's tutorial is gonna be fun! Yes, it's not. So, well, before learning to do fun stuff, we have to learn stupid stuff. I mean, no, sorry. We have to learn smart stuff. Okay, with that out of the way, today's lesson is gonna be about data structures. Oops. Remember comments? They're not gonna come in handy, so why did I say that? Okay, so you remember from the last lesson how we had to include IOStream, and that's ripping off the people who are smart and who made this for us. So, but we don't care about that because they said okay. They said they gave their approval in that IOStream document. It's floating out somewhere there. So let's once again declare these using namespace std. Haha! I will use the namespace, the generic namespace. Okay, well, actually a direct namespace std. Another thing, some tutorials say to use iostream.h. That's not good. iostream.h is a deprecated, I think. What's that word? Deprecated header, which means it hasn't been updated in 10 years and it's outdated. And another bad thing, if you know a bit more about programming or if you programmed in other languages, iostream.h defines all of its like commands like cout, cin, etc. in the global namespace. Well, actually in globally. So that's bad. You don't want to have that many global operations. So if you use iostream.h, you don't have to put this line in, but I definitely recommend against it because all the updates that have been to C++ are all made on iostream. So finishing up that, we'll get into our int main, and once again I can declare void here, which means no parameters, and my return type is int, and here I'll just put this on another line so it's easier to see. Here is my actual code. So I'm ready to code. Let's go. Let's look at some of the data types. Data types in C++, there's a lot of them. There's 1, 2, 3. Okay, I still know how to count. I didn't unlearn it from the last tutorial. Okay, so let's declare an integer. Integer are the basic data types, and yeah. So integers come in two flavors: signed and unsigned. Now, the difference between signed and unsigned integers is that signed integers can be both positive and negative, and unsigned integers are only negative. They're only negative. My bad. Unsigned integers are only positive. I'm having a mental disjunction there. So, what is it called? A cerebral convolution. Yeah, that's the word. Okay, so unsigned integers are only positive, and 1, 5, 10, 15, 20 integral value of something, I don't know, whatever, they're only positive. We don't care about negative values when we put unsigned integers. But then there's problems with using unsigned integers if you want to express a negative value, because you're gonna get some bullshit. Yeah. So, signed integers. If you declare an int using the keyword int, it's automatically going to be a signed integer. So, if you want to declare an unsigned integer, you have to specify it as being unsigned. So, int, now we're giving an int name to our integer. So, my name is going to be x. Keep your names short, please. Well, I mean, it depends what the use is, but for now, you can keep them short. If you want, there should be no this name refers to my integer and then you have to specify for this name refers, etc. You understand? That's pointless and that's wasted time. So I keep mine short because to save time. And int x equals 5. You remember if you took math, int x is a variable. That's pretty much what it is. X is a variable. It's a variable of type integer, so it can only hold whole numbers. And since it's a assigned variable by default, we can put a negative and it will still be fine. So let's declare a float. Floats are cool. Float y, right? A float can hold it can hold a decimal. That's cool. I think decimals are cool as compared to fractions, although I don't know, that's a hard argument to state one way or another. Float y equals 10.5. So that's a float. Also, you could put yf. Well, you could append a suffix f. So if you wanted to make 10.5 a float, you could put a suffix 10.5f and it would be a float. But that's used if you want to, for example, let's see. Well, not exactly, but if you want to say take the square root or use the modulus operator. This is the modulus operator. If you want to use the modulus operator on a really high number, say that number. Oops, so why do I have a 0 in the front? Okay, now it's a really high number. You could append an LL to it, which means a long. A long is a type of integer. It's basically an integer, but it's a double long, so it's very long integer. And long. Now you can use the modulus operator. Otherwise, this number might say too big for type long, and then yeah, it's bad. So if you want to use those, append an LL, which means long, and you're set. So, and let's declare double Z equals 52.36. Sorry. Okay, so these are basic definitions. Let's also include a character. And let's put ckar. I don't know, because it doesn't matter. You could use the Hungarian notation, this is called, and put C in front of it to denote that it's a character. I don't care personally, so I just pick some random name that pops into my mind. And you could declare a character with using single what are these, single quotes, right? And you could put character A, B, C, F, D, B, whatever. Only one though, because a character is the simplest data type and it's the smallest. It can only hold one letter. So a character is basically defined as by the ASCII symbol table, and it has an integer value, all of the characters. So A might have the value 63, I forget exactly, but you could say char ckar equals A, and then you could say cout, put on the cout int c char int. So that would display you the integer value in the ASCII table of the ckar of character ckar. So and let's